Okay, well, we've got a great group signed on, so we'll just get started here. Want to welcome everybody to our monthly webinar. This month we're happy to have Terry Harris back with us again from Reliable Process Solutions. He's going to be talking to us today about effective lubrication storage. So it obviously seems to be a hot topic for folks since we've got such a great crowd. So just a couple things, you know, at UE Systems, obviously we're helping a lot of folks to really improve their lubrication processes, you know, using our grease caddies, using ultrasound to really set up a good ultrasound-assisted lubrication program. But one of the things we find is even those folks who have the best processes in place, if they're not starting at the very beginning with the proper storage and keeping their lubrication clean and free from contamination, that they're still going to experience issues. And so this is a topic Terry's obviously very knowledgeable about and passionate about. So it just seemed the perfect fit and the perfect time since we've been doing some bearing related webinars to kind of take things back to the very beginning here. So that's kind of where we came up with today's presentation with Terry. For those that are interested in a little bit more information about UE Systems, we're always very happy to send our interactive information kit to you. So just pop a note in the chat box if this is something you'd like us to send to you, but it's a really quick reference for everything that our ultrasound equipment can help you with within your facilities, and also some links to previous webinars that we've done, articles, just a bunch of resources that are within just a couple clicks of the mouse. So let me know if that's something you'd like. Also, just kind of housekeeping notes for you all. You are very welcome to ask questions during this program. You just type those questions into the questions box, and Terry will be very happy to answer those for you. Also, we are recording this, so we will be putting this up on our website just a couple days after we wrap this up. So this will be available to those that want to watch it again or have colleagues that maybe couldn't join us today. So just a few housekeeping notes there. And without further ado, we're going to pass this over to Terry, and just bear with us as we change the presenter screen here. But Terry, thank you so much for joining us, and let you take it away.
All right, good afternoon, everybody. And again, like Maureen said, welcome, and we're glad you took the time out of your day for this for the presentation. And I'm hoping everything you can see my screen okay. There we go. Taking time out of your afternoon for this presentation. Like Maureen said, a very important topic, and very important for the people. I've been doing lubrication training at their facilities. Everybody's wanting to know how to design a lube room, what should be in there, and why we need it. A little bit about myself. I own a company called Reliable Process Solutions, and some other things that I do here. I'm the exam director for the Society of Maintenance and Reliability Professionals. I do RCM facilitations, and you can see there are lubrication, auto lubrication programs, training programs, and I also build the plug-and-play lube storage rooms. We'll look at a few of those at the end of the presentation, and some other things with the intent of teaching people how different techniques and different methods that they can use to keep their equipment lasting many life cycles longer. I use this curve in all my training. It's the what I call the PF curve, come out of RCM, but it just shows if you're doing all your work in the finding out information that your equipment's failing by human census or somebody telling you that's failing and you're in that reactive mode, you're going to be 10 or 15% efficient in maintenance. If we use predictive technology such as mechanical ultrasound and some of the other technologies you see on the screen there, we can become 30 to 50% effective in maintenance, because now we can predict failures, we can have the correct parts there, we can actually plan our work and have things there ready for before the equipment fails, and many times correct the issues and eliminate those failures from ever occurring. And then on the left-hand side is the other area, lubrication excellence. These are the things you can be proactive about, doing lubrication correctly, doing precision alignment and balance, and make your equipment last many life cycles longer. And here we can become 70 to 100% effective or efficient in maintenance and actually extend our equipment life. And of course, the reason we do this is because the costs are a lot higher if we're in the reactive mode, and sometimes 3 to 5 times higher by letting things run all the way to failure and then replacing them rather than doing the right things and using predictive technologies. So back to lubrication. One of the things that I do in my lubrication trainings, we talk about the failure modes of lubricants and lubricant programs. And once we understand what the failure modes are, we can go out in our plants, go out with our maintenance teams, and we can look at these failure modes and we can correct the issues in our plants that are causing some of these failures of our lubricants. So some of the 5 major failure modes for lubricants: temperature failure modes, things that cause our lubes to get hotter or be at a temperature where they shouldn't be, and which causes the oils to oxidize. Moisture failure modes, which changes our lubricants to some other compound that's not really a lubricant anymore. So if the moisture is too high, that's going to cause problems. Foreign material and particles in our lubes. You know, one of the things that I teach all my clients and all my classes is that there's particles in your new lubes that need to be removed. So the new lube has none of those damaging particles in it when we put it in our equipment. Many times we assume that new lubricants are clean. We put them in our equipment, we're adding failures to our equipment components. So we want to, part of the lube room and the lube design is filtering all these particles and any foreign material out of our lubricants. Then you have viscosity failures with our lubricants. These can be caused from contamination, overheating, and many reasons. And then other contamination. You know, many of the lube rooms I go into where people are storing their lubes, there's other chemicals stored in there, such as lab chemicals, such as cleaning chemicals, such as food grade and non-food grade lubes. These are contamination issues that can cause short equipment life and cause failures to your equipment. So if we look at some program failure modes for lubricants, and these are like no program and incomplete program. What I've done is I've highlighted some areas where lubrication storage fits into these failure modes. You know, not having procedures for ordering our lubes to make sure we get the right lube and the right additive packages, not having procedures in place for receiving the lubes when they come into your plant. You know, how long do they set outside in the drum? How long have they been sitting at the vendor's location outside, the people you're buying them from? Are they stored correctly? And then what's the procedure for storing the lube after it's relieved? Is it taken to a controlled environment? Is it stored in a clean area where particles and moisture cannot get on top of the drum or the bucket? So developing these written procedures helps improve your lubrication program. If we look down through there, another highlighted area is improper or no offline filtration. You know, one of the things we want to do is with our lubes when it comes in is make sure we filter the lubes and get all the particles and moisture out of those lubes. Additive package separation. You know, many people don't know this, as this is something that I do in the training, but the additives that are in your drums, those additives will eventually settle to the bottom of the drum. And if they aren't mixed or if they aren't stirred up some way in the drum, when you put your device in there to pull from the drum to get your lubricant into your individual containers, there's times when you're going to get more additives, and there's times in the drum when you use all the additives up right away that you're not going to have any. So there needs to be a good way to mix up that lubricant in the drum or in your storage container. I don't know if any of you change your own oil, but a lot of times if you change your oil and you look at the syrupy substance that's in the bottom of the little oil quart bottle you get, that syrupy stuff on the bottom is the additive package. And if you don't shake up that little container, those additives aren't mixed in there. It's the same thing that happens in a drum. One of the things that I learned a few years ago was a metal drum stored on concrete actually creates a charge inside the drums, and it will pull a lot of the additives to the bottom of the drum. So storing lubricants on a concrete floor is not a good practice. What's some other ones here for program failures? No best practice lubrication storage room. Again, one of the things that we do, or one of the things that I do when I go do my training, is we spend a lot of time with the customers helping them design a lube storage area at their facilities. You know, an area that's clean, an area where if it's a really hot area like in South Texas, Louisiana, or California, we want to have some kind of air conditioning in that room to keep the room at some controlled temperature. Now, it doesn't have to be like your house or your office, but some method of controlling the temperature. You know, lube shouldn't be stored in an outside building that's 120 degrees. So we want some kind ambient control. Another one, we don't want the lube stored in an area that goes down to minus 20 degrees. So it should be stored in an area where there's some heat. And like we said, we don't want to store drums on concrete floors. It's a bad practice. Lube consolidation. You know, many times I go into companies that are using 15 to 20, and I was at a company that had 22 different lubricants. We were able to consolidate the lubricants down to 8 different lubricants at a company that had 22. And many times we can get companies, I've been at large companies where we get the consolidation of the different lubes down to 4 or 5 lubricants. Now, a lot of times this means going to some synthetic products or going to combining some viscosities and getting the same coverage. You know, I help people do this for the simple reason of it reduces the chance of mixing the lubes together. And you have less storage and less gallons or barrels on your property. So in lube consolidation, you know, part of a lube storage room is consolidating those lubes and getting them down to the minimum amount of lubes you want to keep in your storage room. Filtration training, you know, many people that I talk to that are going to start filtration of lubricants, they don't understand filtration. There's a lot of training that goes along with filtration on using the correct filter and with the correct efficiency, the beta rating. We'll talk about that a little bit as we go through the presentation. And then ways to reduce moisture. Now, I've found moisture in brand new drums of oil where there shouldn't be, and I also find the way people store oils at their plants, they're adding a lot of moisture to their stored lubricants and just their storage methods. 4 materials, you know, contaminated new oil with particles, improper filtration of the new lubes that come in. We'll explain this as we go through. Improper filtration of the process equipment. You know, one of the things we want to do in our process equipment is filter out the particles that are in the gearboxes and hydraulic units at your facilities. And there's plants that have no filtration practices. They're not filtering new lubes. They're not filtering the lubes that are in their equipment. Not using vent breathers on hydraulic units and not using vent breathers on your stored lubricants. You know, keeping the moisture, these help keep moisture and particles out. Poor lube storage methods and poor lube equipment storage. You know, another thing I try to design in every lube storage room is a way to, or some cabinets or some shelves in there to store your lube equipment. You know, grease guns should be stored in there. Your oil-safe containers or whatever containers you're using to take lubes around the plant should be stored in this controlled, clean environment. So we work with customers to work on those things. You know, if you're in a high moisture area, like I talked about, you know, the Texas coast and Louisiana coast, very high ambient conditions in the summertime, lots of rain. So your lubes need to be stored away from these humidity and wet conditions. All right, let's talk about our new lubes. And one of the things I want to cover here is your new lubes are not clean. One of the things I do when I do a lubrication audit is I try to get there a day or two early, and I go around the plant and I pull samples from new drums of oils, and I pull samples out of some of the equipment just to find out what kind of particles, what kind of moisture are in the new lubes. So the new lubes are not clean. Now, most lubrication companies try to meet this ISO spec of 18, 16, 13, or in that area, or 18, 16, 15. But many times I find brand new drums of oils in plants that are above 20. And these drums many times have only been at the plant for a month or so from the vendor. So that's one of the things you should do is make sure you check your new lubricants to find out how much moisture is in the new lube, how many particles or what kind of particles are in your new lube. But in most cases, and I would say this is in the 80% number, you'll find that your new lubricants are not clean. Here's a lube storage. Drums outside. The customer did take a little bit of effort here to put some covers on top of the drums, you know, to keep particles, keep moisture off the top of the drums, but not a very good storage area for lubricants here. And you can see some of the drums are older drums. I was at a plant in Texas just a few months ago, and we were looking through a storage area very similar to this one, and I found a drum of oil that was dated back around 2000. And what people had been doing with all the storage area, that drum that hadn't been used, it was in the back, and the customer asked me, you know, what should I do with that? Should I filter it? And my recommendation, setting outside for 12 years, 13 years, my recommendation was to dispose of that drum. It had been in the sunlight, it had been through a lot of rain, and the oil was more than likely contaminated, and the additive package was probably consumed. Here's a storage area, and from the picture, doesn't look like too bad a storage area, but this was in a coal-fired power plant. You can see on top of the drums here, on top of the containers, there's not a vent desiccant breather. That's just an air vent. As I went around the room, I could rub my hand across the top of these containers, and they're covered with coal dust. You can see open containers down here that they're using to take lubricants around the plant. A lot of particles, coal fly ash particles in this area. So not a good storage method, not a good storage area. It looked good. And also using these steel containers. I'm not sure what was in the bottom, how much moisture was in there, but it wasn't an ambient controlled room. It got hot in the summer and cold in the winter. So a lot of failure modes with this room. Here's a lube storage, an outside lube storage area at a plant. You can see a lot of their containers, a lot of the barrels sitting out here, the barrel pumps which they were moving between different products. Some bad practices there, some open containers and open buckets, setting out in the plant, collecting particles. Here's a lube storage area at another facility. This is where their drums were stored. This was in the maintenance shop. You can see this is diatomaceous earth and silicone that was used in an oil bleaching process. You can see these bags of products sitting around the shop, and you can see what's on top of the drums. They have open containers here with lubes in them. They did have a filter card, and every once in a while they would hook the filter card up to one of these drums and recirculate it. But not a single maintenance person or the maintenance supervisor knew what the rating was of the filter, and then none anybody could tell me if the filter had ever been changed. So again, some bad practices here which are going to lead to failures of equipment in the plant, which they were having a lot of those failures. So not a very good lube storage area. This picture was taken of the container setting on one of the drums, and you can see the amount of particles in the container. Now I stood back and watched when the maintenance guy came in to get oil. He went in here and he emptied this out, and he took a little bit of effort to wipe the particles out of here, but a lot of particles going to be going into the gearboxes and equipment in that plant. A lot of failure modes. Here's what the top wiped off after he left and came back. This is what was left in the bottom of the container. And you can see here some of these particles just by the flash of the camera. There's some steel particles and metal particles in this container. Now, how many of those went into the equipment? I don't know. I mean, some of these here, these are particles that are way over 100 microns. And we're talking about particles that can damage your equipment that are as small as 10 and 20 microns. Particles you can't see with the human eye. These ones that you see with your human eye in this container here are very, very damaging to the equipment. Here's a plant where they got their these expellers they were using here at this plant. Each one of the gearboxes on those expellers were $250,000. They had 6 of them in the plant. This was the oil that the maintenance guys came into the plant and dumped into the expellers as they needed oil. This is the funnel they use sitting here with. It's dust covered with particles on there that if you can see those particles, they're greater than 40 microns. And so we know they're damaging particles to the equipment. But with an open funnel like that, we're shortening the life of that equipment by many, many years. And they had a gearbox failure while I was at present doing work on this site for a couple months. So again, you have to stop some of these practices. This kind of equipment needs to be stored in a cabinet. The oil container needs to be stored in a cabinet. Many failure modes here. Is this precision lubrication storage? Probably not. We've got containers of new oil in here. We've got containers of used oil in here. And then we're also using this area to store the mop bucket and some other things. So there's contamination issues here in this lube storage room that are going to cause failures and loss of life to your equipment. So why do we need effective lube storage? Well, one of the reasons we want our lube products protected from the environment, from the plant dirt, the FM that could be in the area. We want the lube stored away from any moisture, which could be rainwater, could be humidity. Sunlight with a lube drum sitting outside in the sun, and that drum heats up to 120, 130 degrees in the afternoon sun, and then it cools off at night. You're going to create a little bit of a vacuum in that drum, even if the drum hasn't been open, and we can pull some moisture in. And sometimes we pull moisture when we pull particles in. So the drums, you don't want to store your lube drums in direct sunlight. We want an area we can filter all the plant lubes, the new lubes and the lubes as you use them. A lot of my customers filter the brand new lubes as they come in and put them into the new containers, and then they also filter the lubes before they take them out to use them in the plant. And these are customers that have accepted lubrication excellence as a way of life at their plant. And many of these customers are seeing very, very long life cycles of their equipment, their hydraulic systems, and their gearbox, following these practices. Like we talked about, storage of your lube application equipment. Your containers that you're using to take around the plant. I've got a lot of my customers switched over to oil-safe type containers that have sealed tops and sealed spouts on them. Getting rid of one of the things I teach in my class is getting rid of funnels. Funnels are one of those things that, they're nice to use in a plant. They're nice to use to put oil in a gearbox or a small piece of equipment, but funnels are very hard to keep clean. If you have to use funnels, use the ones that are sealed on both ends, and they can be stored out of the environment. I can remember growing up on a farm, and we would change the oil on the tractors and the combines and the other farm equipment. And we used the same galvanized funnel from the time that I was young enough to remember that hung on a nail in the shop with the same red shop tile in that funnel. And we changed the oil, we pulled the funnel down, we wiped out whatever bugs and debris was in there, and we dumped the oil into the engines. And we didn't know any better, but nowadays we know that those particles are going to shorten the life of the engine. Your grease gun should be stored in a controlled environment. I remember at the plant that I ran for years, my guys would bring the grease guns in. They went into a big, large Ziploc bag at the end of the day, and they went into a cabinet. We were trying to keep all particles off of our grease guns. Any filters you have, spare filters, should be stored in a cabinet away from any particulate or contamination. And again, separating your lubes from other plant chemicals and other plant products. One of the things that I send along with my lube rooms is they're only designed for storing lubes. We don't want flammable chemicals in there. We don't want other products in there where there could be a mistake and be cross-contamination. There's one of the issues that always come up about fire hazards with lubrication storage rooms. Well, lubricants are class 3B chemicals, or 3B liquids. And what that means is 3B liquids are liquids that have a flash point above 200. Well, if you check the product information sheets in your lubes, you'll find out the flash point of lubricants is anywhere from 475 to 525 degrees. So it takes a very, very large fire and a very large sustained fire to keep a lubricant burning. So your fire protection in a lube storage room could be minimal if you don't store any other chemicals in there with the lubes. And it's a designated area where your products can be labeled and separated so that there's no cross-contamination. One of the issues at a Cargill plant about 15 years ago was a maintenance guy went in to get lubricating oil for a centrifuge. He had another lubricating oil in there that was the same number, different product type, but it's for an ammonia compressor. And he put the ammonia compressor oil in the centrifuge, and that centrifuge didn't last 24 hours and caused a number of days of downtime for that unit because it took out all the gears in less than 24 hours. So we want to store our lubes in there and have them properly labeled. Some more reasons. Products stored in a controlled temperature. One of the things I see the grease manufacturers tell you, that store your grease guns on in, and the reason they want you to do that is because if you store them on their side, the oil runs out of the grease cartridge. Well, the reason it does that is because the grease is hot. And the grease gets hot in the plants. I've seen grease stored in plant environments where it's 108 degrees, 110 degrees, or 120 degrees in the storage area. Well, if those greases are stored on their side, the oil is going to separate from the grease, and it is going to run out. But it's still not a good method to store them on in because the grease and the soap or binder are separating, and now a lot of times that grease will be on the top of the cartridge or the bottom rather than laying them on their side where it's evenly distributed. And, of course, as our products heat up, the oil is going to oxidize. So if you're storing your drums of oil in an outside area where it can get up to 110 or 115 degrees, you're cutting the life of that lubricant way down. Because if we remember, if we take a mineral oil-based lubricant, its life is 30 years if we can keep it at 70 degrees. And for every 18-degree rise in that temperature, the life is cut in half. So if we're storing our lubes in an area where it's hot, your lubrication life is going to be reduced down to about 7.5 years already. Product can store it in a controlled humidity area. A lot of the lube rooms I build, we put a dehumidifier in there, or we use the air conditioner to dehumidify if you're in a humid area of the country. The products are labeled and visible. It's a clean area to fill your lube equipment. I was at a plant in St. Croix where they were filling the lubes. The drums were on a rack out in the open air. in an area where there was a lot of saltwater mist, or salt water was in the air because of the ocean being right next to the ocean, a lot of particles in the plant, and they were going up to this rack that was outside and filling their lube containers up. Well, it wasn't a clean environment to get the lube out of the container or fill your container. Another good reason for a lube storage room, and a lot of companies are doing this, this is a standard practice in Cargill. Your lube storage container, every month you go out there and recirculate the container for a couple hours to remix the additive packages in the containers. Very good practice, because some of the additives will settle to the bottom. It's better inventory control, and it's a better way to use the oldest lubes first. I find people doing this all the time. They keep replacing the grease, and they put the grease in the front, and they keep reusing it, and you'll dig back in the back of the shelves, and there's grease and other oil products that have been in there for years and years. Here's a lube storage area. Again, you see this is one of a little bit different area, but kind of same kind of facility we saw before. We have drums stored out here with open containers, funnels, and different things stored in the lube storage area. So we need to take steps to eliminate these failures, way we're storing, and the way we're keeping our lubes and our lube products. So we have to have good storage areas, and around that developing written procedures. So there is a procedure for what goes on with a drum of oil as soon as it comes to your plant. We get it inside, we get it transferred and filtered if possible. And I'm at plants now where drum storage is a real problem. They got to have spill control and things like that. So there are no drums of oil at the plant. As soon as the drum comes in, we take it out of the drum, we get it into the container, and we dispose of the drum immediately. I've got other customers that went to all bulk receiving, where a truck comes in and all the oil is filtered off the truck into their storage areas. Again, you have to be very careful with this, because a lot of the bulk trucks, or the oil and the lubes in the bulk trucks, are very, very contaminated. It's a must for any plant if you're moving into lubrication excellence. I'm sure if you go to any of the NORIA training, you go to any of the desk case training or my training, you're going to hear the same thing. The new lubes are dirty. We need good places to store them, and the lubes must be clean and dry. The lube environment that they're in must be controlled, and your lube equipment must be stored clean. One of the practices that you want to do when you do your lube training is to make sure you train your guys to keep their lube equipment clean, and to keep it in a cabinet or in a covered area when they're not using it. I can't tell you the number of plants where I go around and there's a lube guy on a golf cart, and the grease guns are hanging on the back of the golf cart, and the grease containers are in the back of the golf cart, and he's driving around in dusty, dirty areas, and those containers are very contaminated. Now, we talk about products. I put this slide in here because a lot of the products, if you take any loaded bearing or any loaded gear, the film thickness on that loaded gear is only going to be about 5 to 10 microns. And you can see down at the bottom, those 5 to 10 microns are red blood cells and talcum powder. If you take your hand and run it across the door seal or the top of a picture in your house or your office, the dust particles that are on your fingers are going to be particles that are 40 and 50 microns. And those are like boulders in between a gear or a bearing surface. So we've got to filter those particles out, and we've got to keep those particles away from our lubricants. So how big are these micron particles? This is a slide that Caterpillar put out. This is a human hair, the diameter of a human hair. And you can see these particles on here that we're trying to keep out. You can see a 1 micron particle, and you can see some 4 and 10 micron particles. But these are the kind of particles that we're actually trying to get out of our lubes and keep out of our equipment that's going to cause damage. So very, very small particles. I put these 2 slides in the presentation. This is a slide from a plant that I worked at for years, where the slide on the left, I had one of our guys go up and pull a sample out of a small gearbox in our coal handling operation. And he brought the sample down in a glass jar, and all of my maintenance guys looked at that sample. We all determined it looked clean, the oil looked good. We sent the picture in, and this was the picture that came back. And this oil was an ISO code 221917. And you can see the particles that are in this sample. There's fly ash particles, there's some metal and rust particles. We went up and filtered that gearbox for 5 minutes with a 10 micron beta 200 filter. We sent the sample, the same oil in, and this is the oil that came back on the slide. So with good filtration, proper filtration, we took all those particles out. Now the question I ask everybody when I show them this slide is, how much longer will my gearbox last with the oil on the right rather than the oil on the left? And it's many, many life cycles, 3 to 5 times longer life on that gear reducer by getting all those particles out that can cause wear and cause that microscopic pitting in our gearboxes, our gears and bearings. Here's a hydraulic life extension chart. You can see if we look at the number, the dirty oil number on this side, the 221917, and we come across the page and we filter it down to a 10 micron beta 1000 range, it's 5 times the life on that hydraulic unit. And you know, I've proven this to the plastics plants, and there's a number of cargo plants that are having these successful results by filtering their lubes down to these low areas, down to the 5 and 10 micron range. You know, they're getting up to 7 to 9 times the life out of their hydraulic systems, their pumps and hydraulic motors and hydraulic components, just by keeping the particles out. We talked about moisture a little bit. Look at the difference here if we can take our moisture from 1,000 parts per million down to 50 with moisture control. You know, 6 times the life just reducing the moisture. And some of that moisture comes in our new lubes, and the new lubes are picking up moisture in the way they're stored. So very long life cycle extension with lubrication excellence. Here's the same slide for bearings. Here's dirty oil in a bearing. We clean it down to 10 microns, three times the life on the bearing. So some lube storage fundamentals. You know, develop some written procedures to get your products filtered and stored correctly. Develop some written procedures for filtration standards. You know, what are you trying to maintain? What kind of moisture levels are you trying to maintain in your lubes? How clean do you want your lubes to be in your plant when they're received? Storage. Design an area away from foreign material, moisture, and contamination, and make sure it's ambient control. You know, it should have some kind of an air conditioning unit in, depending on your climate, and it should have some kind of a heater in there. It doesn't take much. Like I say, you're not cooling or heating like you're living in the place, but you're trying to keep the moisture. You're trying to keep the temperature controlled so you don't have these temperature swings and the moisture problems. And then all your lube equipment should be stored in these areas to keep them away from particles. And it's all part of a good lubrication program. Here's a building at a plant. And they had a warehouse area, and they took and put this building up, and this is their lubrication storage building. It's just a metal insulated building in an open warehouse, but all their lubes are stored inside. This is what the inside looked like. So you can see here their lube containers, desiccant breathers in all the containers. They have spill control. They have all their lube equipment in this clean room on shelves. Very, very, very nice lube room. This one here, you say, oh my God, what is this? What kind of a lube room do we have here? But this was at a gold mine in northern Nevada, and we just took a shipping container and put doors on the side of it, and these totes were stored outside in a lean-to for years, and trucks would come by and get the lubes out of these. Well, we just cut some garage doors in here. We put the totes inside to keep them out of the weather, out of the dust. We closed the doors, and it kept them a lot cleaner. Down at the end, we had some small air diaphragm pumps. We actually pumped from the containers back in there to these hose reels, and then the mine trucks basically pulled up here and got their lubes out of these hose reels. Not the perfect condition, but much, much better than what they had before we did the training and before we built this. Here again, a lube storage area using the steel containers. I'm not a big fan of the steel containers, but you know, many of my customers still like to use these. But there's a lot of contamination in the steel container even when they're new, so you have to get that filtered out and do a lot of filter recycling on these when you use them. Here's a customer that had the bulk storage here, and they did put some desiccant breathers up here, but you can see, and as many people do, they let the desiccant breather get completely exhausted. They don't even change it after it's exhausted. So again, we need to, if you're going to use these techniques, we need to make sure we keep the desiccant breathers in good shape. Indoor lubrication storage area with spill control. No desiccant breathers on their containers yet, but they're still working on this. Here's a lube storage room where they have their oil-safe containers in a cabinet. This was a new one. And they're plastic storage containers with their desiccant breathers. Very, very nice setup for a company. Here's a lube storage room. You've seen the picture on the advertisement. This was built for a plant in St. Louis. They had 10 80-gallon containers down here. They brought all their barrels into this room. Each one of these pumps had a lance and a hose on it so they could transfer their different lubes through dual 10-micron beta 1000 filters. So they're basically taking about 99.99% particles out of their lubricants that are above 10 microns. And then this room was air conditioned, as you can see here, got a couple heaters in it, and they were able to bring the barrels in, and they could actually store some barrels in here and keep them warm and keep them out of the environment. But a very nice lube storage room with a cabinet, and so these are some of the things you want to look at when you're designing your room. What all do you need in there, and what all are you going to keep in there? Some workbenches and cabinets where they can get some work done. Spill control underneath the containers. This is a customer. We built a lube storage room for a customer, and we put the IFH steel containers in. They preferred the steel on a rack, but you can see spill control, storage area, the stainless steel workbench, and again, ambient controlled, ready for use as soon as they get there. Here's one store at a plant. This is what one looks like, an installed unit. They kept all their lubricants and lube containers and all the lube equipment in here. There was only 2 guys in the whole plant that had a key to this, and they were actually the lubrication engineers for this whole facility. But again, a very nice installation, everything ambient controlled and everything clean inside. This unit here is actually in a mine that's 1,800 feet underneath Lake Erie, a salt mine. All the lubes are brought in and filtered into these large containers. And then there are these hose reels the mine trucks pull up to these units. And if you've seen the last issue of Machinery Lubrication, there was a whole article about this lube room in the salt mine. They have 2 of these down there. But these small air diaphragm pumps actually pump the oil to these hose reels. And then the mine trucks can pull up outside here. This was in the new condition, but they can pull up outside here and get whatever lube, air, or grease they need for their mine truck. So nobody ever goes in the lube room. The lubes are stored and clean in a clean environment, and the mine trucks and all the mine equipment can get their lubes from the outside. A lot of different options. Good storage area in this picture here of all your lube containers. Your oil-safe containers are stored, your grease tubes, and you can see they've got funnels, but they've got the funnel in a plastic Ziploc bag. Very, very good practices of lubrication excellence. This was at a J.M. Smucker plant in Memphis. They bought their lube room, put it inside. This white lube room sets on the outside of their shop. It was a food plant, so they wanted everything in the unit to be white. So very, very nice setup. No drums ever went in. They set the drums back here, and they actually pump from the drums into the room, into their containers. You can see here's a company that wanted a drip pan and spill control. But again, a lot of different options. You can design your lube room at your plant any way you want it, but just take a little bit of time to design it. Make sure that there's good spill control, there's good drip control, and you have the right things in the room when you get done. Making sure your lines are all labeled so there's no mistakes. This company here used a filter cart to pump all their lubes through these lines, which is not a real good practice, but it was a lot better method than they had before. Again, a lube storage room that was built for our customers. Buckets stored inside. They're all safe containers. Looks like they're spilling a little bit of oil on the floor there, which shouldn't be, but again, a nice clean storage area for a plant. Some good layout drawings available for how you want to lay your room out, what kind of containers you want in there, and then you can actually see how much space you have to do your work. Storage cabinet and lights, and so again, many different options. Here's a 40-foot lube room that a customer built, and he put an office down here. This was sent to Texas, but there's an office down here for the lube technician to keep track of records, keep track of the lubes. 10 pumps, 10 tanks, and plenty of space in here for cabinets and other things they can do in the future. But get another picture of a lube storage area, and then they wanted to store a lot of drums in this one, and then transfer the drums as they used them, but good inside storage. So when you're designing your lube room, look at filtering and storing all your plant lubes. Like I said before, make sure you try to consolidate down and use the minimum amount of lubes that you can use at your plant. Large enough for your lubes and all your lube products. Make sure it's ambient controlled, so you have consistency of the temperature in there. Make sure you have spill control. Now the units can be built with spill control underneath the containers. It can be built where the whole container has got spill control on the floor, or you can set the whole unit in a spill containment pad when you get it there. But wherever room you build, make sure you have some spill control in there. Humidity control, it's going to depend on what area of the country you're in. As we all know, there's areas of the countries that don't have the humidity problem, that don't have this concern, but you have to look at it for your area. Make sure you have enough room in there for your lube application equipment. And like we talked about, fire protection is going to be up to the plant and the local codes you have at your plant. But like I said, if you're just storing lubricants in these areas, fire control can be kept to a minimum with maybe just some sprinkler heads and some fire extinguishers, because the lubricants are Class 3 beetle fluids, and they're very hard to get burning. I've demonstrated this at a couple plants where you take a 5-gallon bucket, put a couple gallons of lubricating oil in there, take a propane torch, stick it in that bucket. It takes a little while to get it burning, and then once you get it burning, if you take the torch away, the fire goes out immediately, and you get a little bit of smoke. So you have to have some kind of sustained heat source to keep the lubricant burning. Now, once you get it burning and you got air exposed to it, it's going to be different, but fire protection can be kept to the minimum in a pure lube storage room. Access to maintenance personnel. You know, one of the selling points of the plug-and-play lube rooms that I build is you can basically set them anywhere. If they get in the way in a couple of years, you can move them, because all you have to do when they come in is plug them into your power source and they're ready to use. And then, of course, make sure you understand the filtration that's going to be there. You know, what oil types do you have? What cleanliness level that you're trying to get to? All right, so that's the end of the presentation. If you have questions, you can send them to me, or you can send them to Maureen with UE Systems. You guys have her emails. And I thank you for your time today. You'll be able to listen to this broadcast again at UE Systems. So I'll turn it back over to Maureen then.
Okay, that was great, Terry. And we did have some questions come in, so we've got some time to ask some of these. So one question that came to mind, you know, a lot of what you're talking about seems like, you know, almost common sense, that if we can put all these best practices in place and these procedures, that it's just going to be a really easy win. So what is it that you find is the reason why folks aren't doing this? And is it, you know, is it really an uphill battle when you go into some of these facilities to get them to start making the change, start cleaning up their process? So what are you seeing as some of those roadblocks?
Well, one of the biggest issues is just knowledge. You know, I think for years that people just thought lubricants were lubricants, and we all assumed that if we were buying a lubricant from a major oil company, that those lubricants were clean and they were dry, and the lubricants were actually what we were ordering. Because I've tested lubricants that were supposed to have additives in them, and the packages weren't there. That's one of the big reasons. The next reason is just like me growing up on the farm. You know, we learn these bad habits at an early point in life. That you just take the oil, any oil is any oil, and you put it in the equipment that's going to work. And so it's basically, or it's all about understanding what these failure modes are of our lubricants and the particles, and then designing our systems around those things.
Okay. Another question, someone was noticing in the photos that you were showing of these lube rooms that lubricants are being transferred through what appears to be PVC pipe and fittings. And so the question is, you know, are there compatibility issues when you're using PVC?
No, there's no issues with PVC. There's some people that say that PVC is not good for lube, but it's kind of if you use PVC and you're using it on hot liquids or hot lubricants, and the lubricant was under pressure all the time, there could be some issues, you know, 5 or 10 years down the line. But just pumping through once a month, or and not actually keeping the piping under pressure, not actually keeping lubricant in the piping, you're not going to have any issues. Now, that's one of the options. You know what, we put stainless steel tubing, we put galvanized and carbon steel pipe in the units, whatever the customer wants, but there's not a problem with the PVC pipe. We slope them all downhill so that the lube doesn't ever lay in the pipe, and it's never really under pressure. So.
Okay. Another question, again, looking at the photos, someone was noticing that in some of the instances you had the breathers installed at an angle, and they had kind of learned that vertical was a better way of doing it because of the moisture collecting. So do you have a preference on that, and is that, you know, something that people need to consider?
Yeah, all the tank suppliers that we're using right now have their fitting for that breather on an angle. In the lube rooms that I'm building using the shipping containers, if we bring them out far enough to put them straight up, they're out there where people are bumping into them. But it's not really an issue. That's only going to be an issue with some kind of breathers. The desk case breather does, if it does get completely saturated, the moisture will drip to the outside. It won't drip into the container. Some of the other styles of breathers, you may have that problem with lubricant building up and getting inside the container. But with the desk case breather, you don't have that problem. And I've never seen any. Well, in a lube room, they won't be that saturated anyway because you're controlling the moisture in the room. But maybe in the field and out in a plant, it may be more of an issue.
Okay. Another question that came in, and it was actually interesting because I actually just took my car in yesterday to have an oil change, but someone was asking, obviously this doesn't relate to the facilities that we're working in, but for, those of us that don't change our own oil, is how do we know, or what are some questions we could ask to know if, the Jiffy Lube up the street or whatever are following these best practices so that we know that these particles and things like that aren't getting into our engines and lessening the life of our vehicles?
Well, that's a real good question, and I'm glad you brought that up because to me it's just as important to understand these principles for your own vehicle if you want your vehicle to last a long time, just like your plant equipment. But you're right, the Jiffy Lubes in those places do not follow these procedures, and many of them are using the cheaper oils that are high in particles and high in other contaminants. Where when you go in there, what you want to ask for is the synthetic blends or the synthetic oils. Those oils are much cleaner than your standard mineral-based automotive oils, and I'm talking about some of your synthetic oils will probably be about 5 to 10 times cleaner than the standard mineral-based oils. And then another thing when you're changing your oil is making sure you use a better filter, because the filter that they put on there is going to be the $2.86 Fram oil filter, where if you ask for a Pure One or a Mobile One filter that actually has an efficiency number on it, those filters are going to be much better for taking particles out and greatly improve your engine life.
All right, good. Well, I'm glad I sprung for the more expensive oil yesterday, so that's good. So some more questions. They're just really flying in here, but it's good we've got some more time. Wondering about if you could, someone just wanted you to maybe kind of repeat and talk a little bit more about when you were saying how temperature can, have a huge impact on the oil life, and you mentioned about even cutting the life in half. So maybe talk just a little bit more about the temperature, and then also, if folks are talking about putting these rooms or really trying to upgrade their facilities, do they really need to even consider putting in an entire HVAC system, or what's the extent of how they need to go for monitoring this temperature, and then of course just kind of talk again about the effect it can have.
Yeah, for all mineral-based oils, now synthetic oils have a lot longer life with those temperatures, but with all mineral-based oils, like I said, and if you go to UE and listen to the 100 failure modes of lubricant presentation, it talks more about this, but a basic mineral oil, if we can keep the moisture out and keep the temperature controlled at 70 degrees, it'll last about 30 years, somewhere around 30 years before it starts to oxidize. But for every 18-degree rise in that lube, now whether it's in the storage or it's in your plant and the operating equipment, for every 18-degree rise in the temperature of that oil, you cut that life in half. So at 98 degrees, your oil is going to oxidize in 15 years. If you add another 18 degrees on top of that, and let's say we go to 110 degrees, your oil is going to oxidize in 7.5 years. And when you get into your plant systems where the plant's operating, you got oils up around 160 degrees. Now those oils are, the life of the oil before it starts oxidizing is going to be down around a year. So temperature is really important as to how long your mineral-based oil is going to last, whether it's in storage or whether it's in the equipment. So it has a huge effect on the life of the mineral oil. But like I say, synthetics are much better than that, and you'll probably get 3 to 5 times more life at that same temperature with a synthetic.
Okay, and for those that have been listening in and are obviously realizing maybe that they're not storing things quite as well as they could be, and maybe even been trying to push to spend some money to really enhance their process. What's like the kind of elevator speech sales pitch that you could suggest these guys use so that they can finally walk into their supervisor's office and have them agree, okay, yes, this is something we need to start spending some money on and really focusing some time and energy on?
Well, the key thing is what we talked about during the whole presentation is if we could. Now, I've went into plants where we've just taken their barrels, they're still using drums, and we put filters on the drums to pull the oil from the barrel, run it through a filter, and put it back into the same drum, and try to get them into an area where it's a little bit cooler or a little bit warmer, where it's not exposed to humidity. I mean, that could be your first step of putting a lubrication storage room in. But if you're going to take the step to do storage, you're talking about things like we're trying to keep particles out of our lubes. We're trying to keep them away from any other contaminants that may be in the plant that could get in there. We're trying to keep moisture out of our lubrication storage. And the best way to do that is to get this into an area where there's nothing else around and we can control the environment. Now, you asked earlier about, do I need to put an HVAC? It kind of depends on what part of the country you're in. I would say if you're in Florida or Texas or Louisiana or in areas where it's, normally hot 9 or 10 months out of the year, and hot meaning above 70 degrees or 80 degrees, I would say you need some ambient controls there in the air conditioning area. And again, if you're in the areas where in the north where it's, gets to 0 or minus 20, I think you need some heat there because the lubes get so thick when they're getting cold like that. It's hard to get the lube out of the container sometimes if you're talking about gear oils. And your greases go through that same temperature curve also with the temperature. So we want to store our greases in ambient controlled areas just to keep the oil from separating from the grease and to extend the life of the grease.
So maybe we'll just do one more question, and then any of the other questions that have come in, we'll definitely get those answered offline. But interesting question that was thrown out there. You keep talking about all this filtering and how important it is to get these particles out. But the question is, with all this filtering, is there any chance of actually affecting some of the actual properties of the lubricant?
Yeah, that's a good question. It comes up a lot, and that's why I start all my customers off filtering at 10 micron beta 1000. Then a lot of my customers, after a few years, after they get their lubrication excellence program up and running, they filter down to 5 microns beta 1000. I've got a few that's went down to 3, but there's no danger in filtering out any additives till you get down around 1 micron, which I don't recommend going there. There's not, for industry, there's not a purpose to go there. If you were in NASA or you're in the airline industry, there are some examples where we filter down that low for different engines and different servo valves. But in industry, about 5 or 10 microns is the limit. But no, that doesn't change the composition of the lube, and it will not filter out any lubricant additives when you go down to those levels.
Okay, well, thank you again, Terry, and just bear with me here real quick. Got some closing remarks, but just obviously want to really thank Terry for being with us today. And what's cool is this was a really good sneak peek into some of the content that you guys would see if you are able to join us at our Ultrasound World Conference, because Terry's actually going to be there with us, and I'll show you the dates here in a minute. But so it's obviously a very important topic that we like so much that we're going to feature it again here in just a couple months. So just real quick, our website, uesystems.com, huge resource for you all. We've got all of our webinars that we host on a monthly basis. All those are recorded and put up on our site, so those are always available for you all to view. We've got all kinds of information about lubrication and all the other applications that our equipment can be used for, and of course all of our other training courses as well. So definitely check that out, and if there's something that you're looking for that's not there, just let us know. We obviously want to be providing you guys with anything and everything that you could need. we hope that you'll stay connected with us. We try to, put these together to try and bring folks together. We've also got our LinkedIn group where a lot of great conversations take place. So if you've got some questions that you still have about today's topic, feel free to take them over to the LinkedIn group and have your peers chime in and help chime in on questions that you see. Just a really great place to kind of build some community and really help each other out. We're also on Twitter. We're at UE_systems, trying to, tweet out different things, interesting articles that we find, and tips and tricks that we've learned along the way. So that's just another place to get some information from us. And then we have our Sound Advice blog where we feature different topics. We've got our Sherlock headphones series, which is pretty cool, and some software information, and we just try to use that as sort of a casual, fun place to provide even more information and resources for you all. So check that out. And then we've got some dates we want to make you aware of. Our next webinar is going to be on April 24th, and we're going to have Ricky Smith from Allied Reliability Group come in to talk to us about fracas. So if you're interested in what that's all about, you'll want to note that date and get signed up for that one. Ricky's a very, very good speaker, very well known, so we're excited that he's going to take some time out to come and chat with us. And then, as I made mention to, we've got our Ultrasound World Conference coming up. It's our 9th annual. We're headed back to Clearwater Beach, May 6th through 10, and as I said, Terry will be one of our featured speakers, so you'll be able to pick his brain about more of this and all the other things that he's aware of. And we've got obviously a great lineup of other industry experts, so it's just a great event, good networking opportunities. So we really hope you'll take a look and see if that's something you can make time and money for. So with your professional development dollars. Also, our training calendar for all of our other courses, our level 1 training, some STEAM examiner classes, et cetera, up on our site. So again, take a look. So with that, I will just leave this up so you guys can take note of how you can get a hold of us. And I thank Terry again for joining us, and thank the rest of you for taking some time out today. And we'll see you next month.